Thank you Hafiz. Nak tidur je kau. Okay. Present now. Yep. Alright. Okay, today we will learn about prime factorization. Last lecture we already established the fact that every positive integer greater than 1 let a be an integer a greater than 1, then a can be represented as uniquely as the product of prime. So suppose this is the first prime times the second prime times until infinitely many primes. P is prime lah. Saya tulis je macam ni. Okay. So how to decompose every integer greater than 1 into primes? So we know this technique as a prime factorization, where we try to let A to be consist of primes, bukannya composite. Contoh, kalau kita ambil okay, 12. 12 can be factorized into 3 and 4. 3 times 4. But this is not a complete prime factorization because 4 is not prime. Okay, it does not establish the fact of the theorem 1. Theorem 1 says that 12 can be represented as a product of every prime. So kalau kita tengok sebenarnya, kalau kita teruskan pengiraan, nanti dia 12 equals to 2 to the power of 2 or 2 times 2 times 3, which is equivalent to 2 to the power of 2 times 3 to the power of 1. Okay, ini yang kita nak cari. How to decompose every integer again greater than 1 to a product of primes. So, ini adalah step asas dia yang di belah kiri. Alright. Suppose yang ni saya namakan C, integer C with the smallest divisible prime less than C in non-decreasing order. Okay. First of all, I would like to list of primes, where it is beneficial if you can remember the small primes. So 2, 3, 5, 7, 11, 13, 17, 18, 19, 21, 22, 23, 27. Okay, cukup dulu. Okay. So pick any number.
So 27 bukan prime.
Oh, thank you. Jadi 29 Thank you. 29 prime. Alright. And okay. So we take any number. Alright. Let's see. Kita ambil lah apa-apa nombor yang besar sikit boleh. Okay. 100. 100 definitely not a prime. So how to decompose it into primes? Saya cuba compare dengan slide sebelah dulu. Dia yang lain ada contoh lagi kat sebelah ni, tapi saya tunjuk dulu step asas ni. Okay, so 100. Try to divide with the smallest divisible prime. Okay, contoh kalau yang smallest divisible prime ialah 2. Okay, kita boleh divide dia tanpa ada baki. It means that it is a prime factor, smallest divisible prime factor to 100, which is 2. 2 divide 100 dapat 50 as the quotient. Okay. Sekarang ni, imagine this will be like a quotient, tak ada remainder, dia kosong. Ni saya kena ulang balik kot. Repeat step 1 till remain this 0. Okay, 50 ni ulang balik step 1, 2. 50 divided by 2 is 25. Okay, right now 25. Can it be divided by 2 without any remainder?
No.
Cannot. Cannot. Kalau mu letak 2 contoh kalau kamu letak 2, 25 bagi 2 memanglah ada jumper quotient tapi ada baki betul. Jadi 12 2 kali 4 8 kali 12 kali 2. Tapi ada baki betul. Baki 1. So 25 cannot be divided by 2 without any remainder. So we proceed to the next prime. Let's say 3. 25 boleh tak bagi 3 tanpa baki?
Tak boleh.
Tak boleh. Apakah seterusnya yang boleh?
5.
It will be 5. Thank you. So letak 5. Okay. So 25 divided by 5 we get 5. 5 divided by 5 we get 1. So when already arrive at 1 we stop. Then this 100 yang kat belah kiri ni semua adalah prime factor dia. So 100 can be equals to 2 times 2 times 5 times 5. So 100 equals to 2 to the power of 2 times 5 to the power of 2. This is a unique representation of 100 in the form of the product of primes. The common question that I get from my student ialah boleh tak kalau dia tak mau bahagi dengan 2 dulu. Okay, dia tak mau bahagi dengan 2 dulu. Dia kata nak bagi dengan 5 dulu. Okay, so kalau dia bagi dengan 5 dulu, 1 bagi 5, 20. And then dia jumble up dengan 2, 10. And then 5, 2, 2, 1. Okay, if you do like this, you still will get the same answer at the end. Okay, the reason why I say we start with the smallest prime first, ada sebab dia. Tak salah pun kalau kamu mula dengan 5 pun. Tetapi at the end, I want you to arrange into smallest to largest, which is very useful for the next theorem. Theorem lepas ni, kita ada guna kalau kita susun prime ni daripada kecil sampai besar. So if you do like the second way, you still divide any divisible prime, you are not wrong, but please it's better at the last answer, you arrange the prime into a smallest to largest together with the power. Kerana bentuk ini, canonical power form ni akan digunakan untuk teorem yang seterusnya selepas ini. Okay. Cuba tengok contoh yang telah saya buat, yang mudah, yang kecil. 30 is consists of 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 1. And if the number is prime, for example like 19, kerana 19 adalah prime, therefore 19, the prime factor is itself. So 19 and 1. Nampak faktor dia. So itulah 19 sama dengan 19 kuasa 1. Alright, cuba kita ambil, saya nak kamu kira sendiri. Okay. Factorize 2020 into primes. 2020 divided by 2, 110, 110. Okay, habiskan step saya. Saya nak jawapan akhir 20 sama dengan kalau dia dapat, minta suarakan mic atau post dalam WhatsApp pun tak apa. Dalam masa 3 minit dah boleh ikut dapat jawapan dia. Kita try to factorize. This is the year 2020. We try to factorize it into the primes. Saya nak tengok student dapat tak idea dulu. Kalau tak, saya kecilkan nilai kalau susah. Alang-alang tu saya bagi lagi satu soalan. Kalau rasa, oh thank you Imran Khairul, you are correct by the way. Imran Khairul dah dapat jawapan. So boleh Imran try lagi satu. 433. Sekejap. Sekejap. Alright, satu lagi cuba factorize 4851 into primes. Okay, Imran Khairul dah dapat jawapan dia. Imran dia claim jawapan dia ialah 2 to the power of 2 times 5 to the power of 1 times 101. Okay, ini jawapan Imran. Yang lain boleh double check. Kalau dah habis, cuba buat yang 4851. Yang ni saya tak mau start. 4851. Berapakah dia punya prime factor? This is a basic skill that everyone must master because it will be used many times along this topic. Kalau yang ni tak mahir atau kurang baik, jadi susah untuk yang seterusnya. So hari ni buat yang ni dulu, bagi make sure semua boleh dapat. 4851 ni lebih senang. Saya dah buat soalan ni, saya baru buat. Dia senang nak cari prime factor dia. Mungkin yang the first one tu saya just pick up to 2020 because this is year 2020. Maybe 101 is a little bit big. Thank you Tacha. Okay, Tacha dapat 3 to the power of 2, 7 times 11. Okay, saya ambil jawapan Tacha dulu. Jawapan Syaza pun sama. Ni Syuhada, okay, alright. Ni Syuhada 733 11 7. Okay, Hafiz betul sama. Alright. Okay. Like I mentioned, Nur Aisyah dapat dulu. Okay. Tak kisah. Janji semua dapat yang sama. Okay. Better at the end, I advise you guys again, jangan tinggalkan jawapan dalam bentuk ini, ringkaskan dalam bentuk power, 3 to the power of 2 times 7 to the power of 2 times 11 to the power of 1. Tak salah kalau kamu buat ni, tetapi macam saya ulang lagi sekali, it will be used at another theorem. Kalau kamu letak dalam bentuk power, nanti untuk for the next theorem, nanti kamu tak biasa. Practice supaya letak dalam power, sama je, senang je sebenarnya. Lebih pendek, lebih ringkas dan boleh digunakan untuk teorem seterusnya. So, practice untuk letak dalam bentuk power. Okay? Kenapa Akram aik? Dapat lain ke Akram? Check balik. Kalau jawapan tak sama, check balik. Sebenarnya senang je kita nak check balik. Okay. First of all, how to ensure your answer here, contoh korang dah dapat ni, betul ke tak? Pertama sekali, all of them must be prime. That is very reasonable. Mesti prime. 3 is prime, 7 is prime, 11 is prime. And then to ensure that you are correct, like Akram said, yes, darab balik lah. You multiply it back. Will you get 4851? But if you already done your step correctly at the first step, usually you are correct. Selalunya betul. Macam ni syuhada, dia bahagi dengan 7 dulu mungkin. Tak ada masalah. Tak ada masalah. Tapi dia bahagi dengan faktor yang betul. Jangan bahagi dengan faktor yang tidak betul. Lagi teruk, the worst case is that they divide it by non-prime. Divide it dengan composite lagi lah salah. Jangan divide dengan composite, divide dengan prime, because again kita nak cari prime factor. So when you multiply this back, 3, 7, 11, you will get 4851. Alright, for the last one more example, kita nak training. Cuba kita ambil lagi satu contoh. Saya buat soalan sekarang. Okay. Okay, H 3, 7, 2. Factorize it into prime. Ini last question untuk prime factorization. 8, 3, 7, 2. Very good, Archa, Mohsin. The answer is correct. Itulah cara saya buat soalan pun. Saya ambil beberapa prime and then saya darabkan, dia jadilah satu nombor komposit. I take several primes, I multiply, I will get a composite integer. 23 is prime, yes. Okay. Saya letak dulu jawapan Tacha dengan Musin, dengan Imran dan yang lain-lain. Saya rasa dapat jawapan yang sama. Dah dapat dah, kata rentak dia. 2 to the power of 2 times 7 to the power of 1 times 30 to the power of 1 times 23 to the power of 1. Okay. Nice. Okay, satu minit. And then I will address some of the common challenge when students are trying to do prime factorization. Bila dah sampai ke tahap ni, dia dah mahir, and then for example, like Hafiz said, 23 is prime. Nanti saya bagi tahu apa masalah student yang itu. Hafiz tak ada masalah nampaknya, dia tahu beberapa nombor prime. Dan saya perasan, I realize that Hafiz also identify that 101 is a prime. But not all students manage to recognize those, especially when they're given a very large prime. Okay, so I will go back to the first question. Jawapan last tu kamu tengok kawan kamu 2 to the power of 2, 7 to the power of 1, 13 times 23. Okay, I go back to this question. Mungkin sedikit saya mula dengan soalan yang student selalu ada masalah ialah bila dia sampai 101. Okay, first of all, okay, saya buka keseluruhan. Okay, I think you don't have a problem when you are this stage. 2 saya dah buat, so 5 dapat 101. Sampai 101, we try to divide by 2 cannot, 3 cannot, 5 cannot, 7 cannot, and then 13, 19. When you are trying to divide a small prime, you will not find the prime factor first. I believe that some of you already encountered that experience. Divide by 2 cannot, 3, 5, 7, 13, 19, tak boleh ni, 23 tak boleh. Okay, at this point, if you cannot identify that whether the number might be prime, it might be prime. So what I advise the student is that remember theorem 2. Theorem 2 kita dah go through last week, last Tuesday. Ni. If you suspect that that number might be the prime number itself, you can use the primality test. So the step of primality test, jangan lupa pula, okay? 101, where I suspect it might be prime. So what I need to do is, if it is indeed a prime, there will never be a prime factor up until less than or equal to square root of 101. If 101 is prime, then there does not exist prime factor less than or equal to the square root of 1. Vice versa, if it is a composite, there exists prime factor less than or equal to square root of 101. Kalau tidak prime, maka composite lah. So, square root of 101 is very small. It's approximately 10.05. Okay, so saya tengoklah, saya carilah prime factor up until 10. So 2, 3, 5, 7. Inilah prime factor less than 10.05. What I need to check is very simple. 2, can it divide 101? Cannot. 3, cannot. 5, cannot. And 7 is not a prime factor of 101. Based on theorem 2, it already saved many time of searching. You don't need to divide by 13, 19 and so on. Cukup dah sampai 7. There is no prime factor up until 10. Therefore, I can conclude that 101 is indeed prime itself. Therefore, when you arrive at this 101, you just divide by 101, then you stop at 1. then it's confirmed that 2020 is equal to 2 times 2 times 2, 2 times 2 times 5 times 101. Because the prime factor 101 is indeed the prime number itself. When you arrive at a very large prime, pergi ke theorem number 2. Langkah dia pendek sahaja. Okay, do you have any question at this timing? Okay, saya cuba besarkan sikit. Ni saya saja nak tunjuk kalau in case student forget about the primality test. 1001, is it prime? Ada yang nak cuba? Kali ini Hafiz dapat tak jawab? Adakah 1001 adalah prime atau composite?
Bukan prime.
Bukan prime.
Composite.
Kalau composite, apakah faktor dia? Nampak? Apakah prime factor dia? Boleh? Musim beritahu.
7.
7. Okay. Musin said that 1001 is composite. Maka kalau dia composite, it has more than 2 prime factors. More than 2 factors, which is 1001. Ada satu lagi. So, Musin cakap 7 adalah faktor kepada 1001. So, saya teks sekejap.
13 sekali.
13 sekali. Weh, laju kau. Okay, 13 sekali. Lagi? Ada lagi tak? Banyak. Okey lah, bagi tahu terus lah 1001 sama dengan berapa? Okay, by using prime factorization, 1001 is equal to 7 to the power of what times 13 times berapa? Habiskanlah, ala-ala.
11.
11. Habis ke? Yes. 7 to the power of 1 times 13 to the power of 1 times 11 to the power of 1. Very good, guys. Mantap. Mantap benda. Mantul, saya balas balik. Mantul. Okay, we already finished at prime factorization. We will skip for a while division algorithm for us to have. Right now, you have the momentum of prime factorization. Usually, for the other subject and this subject as well, I will go straight to this GCD. Okay, we take a break for 2 minutes. 2 minutes, right? Ni break pendek, break pendek. Cuba makan. Esok baru ingat nak relax. Sekali ada problem lagi dengan korang. Harap tak boring lah program esok. Sebagai bapa PA, kena join, yes. Semua kena terlibat. Tapi macam biasalah, kalau saya boring pun, saya tutup mic, of course saya tutup mic, tutup kamera lagi lah. Oh tak, saya tak bagi talk. Dia hanya kepada counselor. Counselor akan bagi talk, and maybe they expect the student to express themselves. If the student have problem, try to share it. Oh, by the way ya, anak-anak PA saya, dengar anak PA saya, hari tu saya silap baca. Rupa-rupanya bila saya check balik, template yang digunakan kepada kamu tak sama dengan template senior kamu. Template senior kamu dia letak expected GPA, yang kamu punya bukan expected GPA. Saya rasa dia letak GPA metrik kamu. So untuk anak-anak PA saya, tak ada expected GPA tu, saya kena kira balik sendiri. Okay? So kepada Aizat Haikal, Farhad, Nik Nur Syahada, apa tu, Sun Ken Yuan, siapa seorang lagi? Wan Maisarah. Saya akan kira balik expected GPA, but in the nutshell, keputusan korang okay. Tapi saya salah cakap expected GPA, malu saya. Saya dah perasan dah, selepas tu saya relax dulu lah. Nak announce terus. So tomorrow, I expect that active participation from you guys to the counsellor. Tapi saya best korang ni, banyak lecturer yang mengajar beri komen yang positif. They say that you guys as a bunch, as a batch, as a whole, are very active in class. They like that. Of course lah, siapa tak suka kalau student asyik berinteraksi, bagi respon, bukan waktu bila dah habis lecture, thank you, time tu lah baru dengar suara. Memanglah. But I really expect everyone, saya sebenarnya macam, saya tak kisah sangat kalau honestly lah, kalau student tu bagi respon ke tak. Kalau tak bagi respon, saya proceed je lah nak buat macam mana. Tetapi the more that I concern is that they actually understand or not. Kalau dia diam, tapi kalau dia faham, okay. Niat saya mengajar nak faham, nak budak faham. Kalau diam tapi tak faham dan dia diam, still diam, itu yang jadi masalah. Itu jadi masalah. Kita tak boleh paksa student atau manusia untuk bercakap. Dan ada setengah student, kalau dah memang dia faham, dia diam lah. Buat apa dia nak cakap kan? Tetapi ada setengah manusia, kredit tu Musin contoh, yes, maybe Musin, dan yang lain bukan Musin je kan, yang lain pun ada, dia malu nak cakap, dia tarik. The sharing is beneficial for the other students. Betul, student lain dia benefit, yang tak faham tu, yang malu nak bertanya tu, dia faham lah kerana orang-orang yang aktif dalam kelas ni. So kita balik kepada GCD. Hafiz Hakimi keyboard warrior, suka bagi hiburan, bagus saya. Sono Mana Adam? Adam senyap hari ni. Mungkin Adam yang tidur hari ni bukan Adam saya Adam tu. Adam tu lah. Adam cakap, saya nak bagi nama. Oh ada. Adam Swardi, alright. Bagus, okay. We go to the GCD kita fokus balik Tadi tu iklan sekejap je. Okay, greatest common divisor and least common multiples. So before we proceed to the next idea, when we are talking about GCD, and some say HCF. HCF is highest common factor. Common factor di divisor. Saya dah cakap divisor dengan faktor adalah benda yang sama daripada perkataan yang beza saja. Greatest and highest also the synonym, right? Therefore, when we talk about GCD or greatest common divisor, it must involve more than one number. Contoh, find GCD between 20 and 10. Okay, saya ambil yang kecil dulu. 20 and 10. What is the divisor for 20? Not prime divisor. Divisors. Semua.
1,
1, 2.
5, 10, 20.
Thank you. Cemerlang. 10 pula. 1, 2,
10.
10 only. And between these divisors, which are the great common one? Saya tak pergi greatest lagi. Common divisor.
1, 2, 5, 10.
1, 2, 5, 10. And between these sets of common divisor, which one is the greatest one? Kita dapatlah satu saja nilai 10. Okay. This is a old school way for you to find the GCD, right? You list down all the divisors, you list down all the common divisors, then you find the greatest one. However, for your level, is that ni dia punya definisi saja. By using prime factorization, how to find the GCD? Okay, so ini alamak. Okay, saya menggunakan contoh yang sama. Find the GCD between 20 and 10, but this time I want to use prime factorization. By using prime factorization, you need to factorize 20 and 10 into prime factors first. Prime saja. 20 sama dengan 2 kuasa 2 darab 5 kuasa 1. 10 to the power of 1 times 5 to the power of 1. There is a theorem associated with prime factorization and GCD. Given any a, b as an integer, where a has been prime factorized and b also has been prime factorized, it states that this GCD between 20 and 10 is just a product of prime numbers to minimum 2 and 1. Mana saya dapat? Daripada sini, nampak ni 2 ni. We take the powers out and try to find the minimum between 2 and 1. Okay? Times 5 minimum 1 and 1. 2 yang mana lebih minimum? 1 times 5, 1. Therefore it will be 10. Jawapan sama dengan atas. So by using prime factorization technique and by using the specific theorem, you can actually find the GCD between any integer by using the concept lah. The first prime minimum, second prime minimum times the last prime minimum. Okay, let me show you another example. Find GCD between, I take 49 if I may, 49 times 49 and 25. Alright, by using prime factorization, please. Okay, this one you will answer 49 equals to 7 to the power of 2 and 25 is 5 to the power of 2. Right now, if you want to collect this together, GCD between 49 and 25, you will have a little bit problem to establish the powers. Contoh, kalau saya letak 5, minimum apa? Okay, for this case, if there is no prime here, for the 49, there is no 5 as a prime factor, you need to recreate 5 to the power of 0. Because any integer to the power of 0 is equivalent to 1, so it is okay for you to create a dummy variable for it to be comparable. So 5 minimum 0 1, and same goes for the 7 1. You need to develop a dummy variable 7 0, so you can compare 2 and 0 times 7 minimum 2 0. Therefore 5 to the power 0 times 7 to the power of 0, it will be 1. The GCD,
Sir,
yeah,
why is 5 minimum 0, 1?
y 5, 2. Thank you. Saya tak nampak. 5 minimum 2, okay. 0 2, okay, saya double check. Minimum 2 0. Minimum between 0 and 2 is 0 0 1. Thank you. I need to charge my laptop, gelap. Okay. Charge kejap. Okay, so the GCD is 1. By using prime factorization, we already established the fact. Okay, so if the GCD between any two integer is 1, we call this relatively, nantilah, nanti tak confirming pula, nanti. Saya bagi contoh dulu. Determine GCD between 8 and 20 based on the step. You boleh tengok dulu yang kiri, dapat idea. And if you already get it, try to find the GCD between sekejap saya tengah fikir nilai, susah nak dapat nilai terus ni. Saya cuba serandom yang boleh lah, 50, 100 and 2, 3, 4. Boleh tak? Dapat tak jawapan yang cantik? So 100 equals to 2 to the power of 2 times 5 to the power of 2. 2, 3, 4. Saya tak cari lagi. Berapa? Oh, tak cantik. Padam balik. Hai. Okay. Okay, kali 4. Saya terbalikkan nombor, terus cantik. 4, 3, 2. Berapa? When you already factorize 42 into primes, then you can use the theorem. Cari dulu prime factorization of 42. And by using the theorem, you collect it to be representable as the same common prime. 2 minimum berapa? Kita dah ada dah untuk 100. Cari lagi 1 times what? Next. Habis kan?
Untuk 432 equals to 2 power 4, 3 power 3.
3 to the power of 3, okay? Thank you. Lepas tu cuba masuk terus dalam teorem ni. Okay. 2, we have a common 2. So 2 and 4 times 3 minimum tunggu saya cakap. Okay. Because 3, 0, tak ada kat sini. 5, kita kena create 0. Therefore 3 minimum 0, 5. Lajak. 0, 3 times, saya besarkan lah, serabut. Times 5 minimum 2 and 0. So you just take 2 minimum 2 to the power of 2, 3 to the power of 0 times 5 to the power of 0. You will get your GCD between 100 and 42 is 4. Okay, some might argue why what is the advantage of by using prime factorization to find the GCD? Okay, my simple explanation to you is that the advantage if you use prime factorization technique to find the GCD, it will be much faster in the computation time sense. For example, if I want to use the normal old school way, find the factor of 100. So it will be quite plenty for you to list down 1, 2, 3 ada, 4 pun dia, 5, 6, 7, 8, 9, 10, banyak, tak habis lagi ni, 10, 25. Okay, 1 there will be 100. If 2 there will be a 50. If 4 there will be a 25. Okay, 4, 25, 5 dengan 5 satu ni 20 and 10 dengan 10. So this is the factors of 100. 432 pula banyak juga, 2 432, malas nak cari ni, sekejap. 432 bagi 2, 216 and then 3 and 144, 4 and 108. Ada lagi ni, common factors, common divisor, and then you kena list down 2, 4, blah 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 blah, and between them what is the highest one. The method is tedious and it is computationally expensive. It is time consuming. That is the major advantage for this difference between the conventional method by listing and by using prime factorization. And bear in mind, this is for 100 and 432. Okay, it's only a 3-digit numbers. Just now we only to use 2-digit numbers. Korang boleh nampak kalau 2-digit numbers guna listing cepat, guna GCD pun lebih kurang sama cepat. But if I try to extend the digits GCD kepada 3 digit, dia dah jadi makin lama. If I extend it to a billions or millions or to billions to trillions, then it will be a couple of hours for you to find it, even by using maybe prime factorization. Saya tak sempat nak demo guna Python sebab saya ada develop satu short program to find prime factorization. Saya tak cari balik lah untuk korang setakat ni. When we learn Python, which you will learn at someday, next 2 semester, I already developed the Python program to find the prime factor. Tujuan ni saya ialah saya nak buat soalan untuk student nanti senang. Saya nak tengoklah soalan tu cari prime factor dia apa semua. And then I test my program up until a very large integer. And it's proven to be successful, but if given a very large integer, it will take some time, even for my computer. Tapi lain kali kalau korang belajar Python akan nampaklah benda tu. Sekarang ni korang kira manual, but using the knowledge of that prime factors yang korang belajar hari ni, korang boleh guna untuk aplikasi dalam Python. Okay. We go to LCM. Okay, prime factorization, ada soalan tak untuk setakat ni untuk menggunakan GCD? If your prime factorization capability is good, you just apply the theorem. If you don't have a common prime, you develop a dummy prime with the power of 0. Kalau tak ada, kena create dummy prime, cari minimum. Okay, and then you will get the answer. And if GCD is by using the minimum power, LCM pula, saya direct cakap LCM you just maximum. The first step is the same, you need to prime factorize and then you need to combine them together into the power form. The difference is just maximum. Okay, so let me demonstrate.
Sir,
Ya,
kalau nak tanya yang pasal primality test boleh ke?
nanti dulu. Nanti
Okay,
boleh. Ni siapa ni? Akram lah. Okay, nanti saya buka lepas habis sesi GCD dengan LCM dulu.
Okay sir, thank you.
Right. Okay. When you already master the GCD by using prime factorization, right now, directly use the thinking to find the LCM between 100 and 432. Okay, the same value. So with the same prime factorization, the difference is right now, if you want to find the LCM between 100 and 432, is just different in terms of maximum. Maximum 24 times 3, maximum 0.3, 5 maximum, 2, 0 becomes 2 to the power of 4 times 3 to the power of 3 times 5 to the power of 2. Dapatlah jumlah yang agak sederhana besar. 16 times 27 times 25, it will be 10,800. This is the common multiple between 100 and 432. The difference is just maximum compared with the minimum. Maximum, minimum, minimum, maximum. Okay, by the way, what is least common multiple? Sorry takut sebab saya terskip ni. Tapi sebab saya assume you all budak dah level ni, boleh ingatlah sikit kan. Okay, what is least common multiple? Tadi tu faktor, sekarang multiple. So what is the find LCM between 3 and 4. 3 and 4 sekecil sangat. 4 and 10. Contoh So what is the multiple of 4? 4, 8, 12, 16, 20. Ada lagi lah 24, 28, 32, 36, 40. Okay, cukup. Then and many more actually dia bukan stop kat 40 je, nama pun multiple kan. Okay, for 10 is 10, 20, 30, 40, 50, 60, and so on. And between them, what is the common multiples? You have 20, you have 40. Right now lah, there are more. And between them, what is the least one or the smallest one is 20. Okay, this is if you use the conventional method, and if you use a prime factorization method, it's very simple. First of all, you need to factorize into primes. That 4 is 2 to the power of 2, 5 is 2 to the power of 2, 2 to the power of 1 times 5 to the power of 1. And by using the theorem, the LCM between 4 and 10 is 2 maximum, 2, 1, 5 maximum, 0, 1. Then it becomes 2 to the power of 2 times 5 to the power of 1 becomes 4 times 5 becomes 20. The same answer, but perhaps more elegant. Okay, ada soalan setakat ini pasal LCM?
Soalan tu ada ke dia macam between nombor negatif?
Okay, between a negative number. Okay, very good. Hafiz, kita sekarang ni bincang negatif sekejap. Soalan saya, pernah ke saya tanya negatif? I really cannot recall right now. But what Hafiz asked me right now is about the presence of negative integer. Okay, kita padam jap. Okay, before I start establishing the fact of the integer, a negative integer, let's look for a while the definition of a divisor. If let A be integer, A divides B if B equals to A times C, C is an integer. Ini yang benda hari itu. The definition of divisibility or factorability. So persoalan ni sekarang, bolehkah kita ada negative factors? Okay. Example, is negative 2 factor of 8? Wujud tak negative factor? Negative 2 is, if it's a factor of 8, then 8 can be represented as negative 2 times C, and C is an integer. And based on this definition, 8 equals to negative 2 times negative 4. Of course, negative 4 is indeed an integer. As a result, negative 2 is indeed a factor of 8. The fact that if integer, tak boleh. As a matter of fact, based on this conclusion, orang panggil, kata apa ni, empirical conclusion is that there exists negative integers, negative factors. Okay, kita establish dulu bukti ini. Saya boleh tunjuk untuk semua sebenarnya. Okay, ini mungkin setengah student suka lah kot. I try Secara keseluruhan, let A be a negative integer. So katakan if negative A divides B, ni untuk keseluruhan nombor let A be integer dan negative A sebagai negative integer. Jika negative A merupakan faktor kepada B, then B equals to negative A times C. This C must be integer. That's all. I think there is no problem. B equals to, kalau kita jadikan dia A, B sama dengan A times negative C. Negative C still integer. As my conclusion, there exists negative integer such that for every B. Okay, ni idea pendek saya yang saya tak revise lah. Tapi penjelasan saya, jika A divides B, maka negative A also divides B. Okay. Jadi negative factor wujud, negative multiple pun wujud sebenarnya. Okay. Negative factor exists, negative negative multiple also exists. So we go back to soalan posed by your friend. What if the GCD between 8 and negative 8? Okay, soalan ni, okay, kalau kita nak selesaikan dalam cara lama, we list down the factors. Then it will be 1, 2, 4, 8, and because of my previous explanation, that also exists negative factor, negative 1 also is the factors, negative 2 is also the factors, negative 4 and also negative 8. And for negative 8, apakah faktor negative 8? Kalau ada 1, dia mesti negatif 8. Kalau 2, mesti negatif 4. Kalau 4 kali apa? Negatif 2. Kalau 8, negatif 1. The factor remains the same. But which one is the greatest one?
8.
It will be 8. So if you use conventional method, then you can solve it. GCD between A and negative A, or 8 and negative 8, it will be 8 itself. But the question is this, a concern arises. Can it be used as a prime factors? Can it be solved by using prime factorization? Yang ni kita ada masalah. Suppose I try to use prime factorization. Logically speaking, prime number mestilah nombor yang besar daripada 1. It must be positive integer greater than 1. There should be no problem for 8 where it will be 2 to the power of 3. Negative 8, ini masalah. Ini masalah. Negative 8, you try to prime factor dia, tak boleh. Kalau you nak buat, cubalah kita paksa. Negative 2 is not a prime. 2 is prime. Okay, 2 is prime. Tapi 2 to the power of 3. Bukannya negative 8. Betul? Dia kena negative 2 to the power of 3. But negative 2 is considered not prime. Based on the definition of prime, it must be larger than 1. What I want to say is that I don't think it's possible for us to use to force prime factorization idea into presence of negative integer. Tetapi kalau macam contoh, kalau kamu tanya apakah GCD itu 8 dengan negatif 8, boleh kita cari. Tapi it's not by, definitely not by using prime factorization. Itu saja saya punya penjelasan. Okay, clear?
Clear, Doktor. Thank you.
Dalam
ini GCD.
Ya? Oh, tak ada. Okay. Silakan, cepat-cepat.
GCD tu kan apa kan? Kalau
Ya.
dalam kes ni lah. Kalau LCM satu kan?
Kalau LCM kita tengok.
Bukan. LCM dia 8 lah.
Ulang balik. Kalau LCM,
GCD. LCM tu Sepatutnya berapa kalau dalam kes 8 dengan negatif 8?
Okey. Apakah LCM antara 8 dengan negatif 8? Alright, ni GCD kita tolak tepi sekejap. Kalau LCM between 8 and negative 8, dan secara penjelasan saya tadi, kita tak boleh secara logik guna prime factorization, tak boleh. Sebab kita tak boleh faktorkan negatif 8 ke dalam primes. So kita abaikan dulu yang ni. Cuba tengok kalau kita guna cara lama. 8, what is the multiples of 8? 8 kali 2, 16, 24, 32.
Banyak se.
Banyaklah, sekejap lah. 8 kali 5, 40. Ya betul lah banyak, tapi kita nak bantu faham Okey, negatif 8 pula. Apakah multiple negatif 8? Yang ni yang student confuse. Okey, kita pergi ke sini sekejap. Okey, kali ni negatif 8 adalah faktor. Apakah multiple di kanan? Negatif 8 salah satu multiple. Negatif 16 also salah satu multiple. Negatif 24 salah satu multiple. Dan wujud juga 8. Sebab negatif 8 times negatif 1, it will be 8. Negatif 8 times negatif 1, it will be 8, 16, 24 and 8. Persoalan sekarang ialah the least common multiple untuk 8. Kejap, wujud tak negatif 8 sebagai dia punya multiple? Kita balik kepada definition. If A divides B, then B equals to A is C. Okay, adakah 8 faktor kepada negatif 8? Ni multiple kan? Kanan ni multiple, kiri faktor. Negatif 8 sama dengan 8 kali C, C adalah integer. Negatif 8 sama dengan 8 kali, boleh tak? Boleh.
Negatif 1.
Negatif 1 pun adalah faktor. So untuk kita senaraikan multiple untuk 8, dia boleh juga negatif 8. Negatif 8, negatif 16, negatif 24, negatif 32. So LCM itu 8 dengan negatif 8, kita ambil nilai yang kecil ialah negatif 8. Dia terbalik dengan faktor. It can be found, but we must establish the fact that exists a negative factor yang mana saya sudah prove kat atas ni. Kalau kita ambil negative multiple pun, let A be an integer. I want to prove that B is negative integer. If A is a factor of B, I have a theorem that then A is also a factor of negative B. Ini saya punya hypothesis. Of course A is a factor of B. Ini boleh tunjuk nanti Tengman bolehlah nak dapat idea untuk tunjuk. Tapi saya nak cepat, saya nak tunjuk. Kalau A is a factor of negative B, then negative B kita boleh present sebagai A darab C. C adalah integer. Dan memandangkan B adalah multiple kepada A, B juga boleh kita transfer kepada negative sign A times C. Or B equals to A negative C merupakan also integer. Ini case ni C adalah integer, betul? Yang kedua pula, kalau kita tukar form dia pun negative C pun adalah integer. So tak ada masalah. Kalau B merupakan negatif punya multiple, maka dia masih boleh wujud jika B adalah positive multiple untuk A pada asalnya. Alright, kita dah 11.24. Soalan Akram tadi tu saya simpan sekejap. Saya akan simpan. Saya nak habiskan yang ni dulu. Okay? Alright. when we are already clear about GCD and LCM, actually saya suka pula bila ada student tanya pasal negative integer tu. Jarang student tanya. Tapi kalau tanya tu dia membuka minda kita. Tak tentu saya tanya kan. Mungkin saya tanya. Dia pemikiran yang level yang lebih orang kata analisis. Bukan sekadar faham. Dia fikir, oh dia dapat nampak. Dan kita boleh nampak pengetahuan baru kalau ada pemikiran macam tu. Okay. Alright. Tadi kita dah tahu cari GCD. We already know how to find LCM by using Primality method. Now there is one more theorem that is more interesting, which is the product between two integers is equal to the product between the GCD and the LCM itself. Contoh. Okay. Contoh the theorem states that AB be an integer, then AB is equal to the GCD between AB times LCM between the same AB. Contoh saya ambil contoh yang kecil. Okay. Saya cuba nak cari example GCD Okay, tadi kita dah buat 10 dengan 20 kan? Okay. GCD between 10 and 20. Berapa tadi? Sorry saya lupa. 2/1 dan 5/1. 20 sama dengan 2/2 times 5/1. So GCD dia sama dengan 2 kali 5, 10 kan? Sekejap, saya dah baca. 10, 2 kali 5, 20, 4 kali 5, minimum 2/1 kali 5, 10. Alright. Okay. Right now, by using this knowledge, we know that 10 times 20 is equal to the GCD between 10 and 20 times the LCM between 10 and 20. Maksudnya, kita tak cari lagi LCM tu berapa, betul? Tetapi by using the knowledge of the GCD and the product of between 10 and 20, you can already know what is the LCM of 10 and 20. Based on this fact, 200 is equals to 10 times the LCM. Therefore, LCM between 10 and 20, you just take 200 and you divide it by 10 is equal to 20. As example more here, kalau kita tahu GCD 820/4, kita boleh tahu LCM 820 dengan cepat. But not by using, you don't need to use prime factorization. Oh, sekejap, saya dah tutup lagi. This is just a kata mathematical fact. The product between any two integers is equivalent to its GCD times its LCM. Itu pengetahuan dia. So kurang soalan, saya nanti kena kumpul balik soalan supaya korang boleh jawab. By the way, dalam tutorial TMS tu ada soalan-soalan seperti ini. Yang ni kita KIV kejap. Saya nak rehat sekejap dalam masa 5 minit. Nanti kita akan mula balik dalam masa 5 minit. Saya terdengar GCB MACD. Saya bagi 2 bintang je daripada 5. Selalunya kalau lawak betul saya bagi 5 bintang. Ini lawak GCB MACD ni 2 bintang je Okay, rehat 5 minit. Kau pula pasang, Ishraf. Saya nak makan jap, roti bagi habis. Seorang pasang lagu, tak kisah, bukan semestinya saya ni. Ishraf present, pasang lagu apa kau nak. 5 minit kita mulai. Ha, 2 minit lagi, cepat. Okay, we will start back. Apa ni? Oh, very good. Tengman letaknya punya sini. Saya baru tengok WhatsApp. Tengman try to prove. Oh, kecil kat tulisan. Saya kena. Very good ideas presented. Okay, very good. Cuma saya tak baca betul-betul lagi lah. Okay, we will continue back with the division algorithm. Tadi kita dah clear prime factorization sedikit. How to find the GCD and LCM by using prime factorization. And also you already know how to, you already know the fact that the product between two integers is equivalent to the GCD times the LCM. Okay. Now we go a little bit backward to find the division algorithm.
Saya present sir.
Oh, okay. Okay, we start with the fundamental first. How to divide? Okay, we take 18 divided by 3. How to divide 18 with by 30 by 3? Almost everyone do it this way. Okay, so we right now have 18 as the dividend, the things that we want to divide. 3 is the divisor. Eighteen divided by 3. Alah, ni bulat, tak cantik. Tak cantik, tak cantik. Saya tukar sikit boleh ya? Nineteen. Okay, baru ada baki. Okay, 19 divided by 3. 6 times 3, 18. This 6, we call it quotient. And bahagi tolak dapat as a remainder. Wait a minute, I want to pause the video for a minute. Sekejap, ada orang panggil sekejap. Okay, sorry, saya sambung balik. Okay. Alright, this is a common process by everyone knows this. Therefore, we can represent it as a linear equation form. 19 equals to 6 times 3 plus 1. If you change it into this form, then this again, this is a dividend equals to divisor. Sorry, ini adalah quotient. Q, divisor, this is R. In the notes, it shows that this can be represented as M equals to Q N plus R. Okay, every number can be represented as division algorithm form. So for example, represent 20, tak boleh kecil, asyik kecil je, saya ambil besar sikit boleh 200 divided by 13 by using division algorithm form. Alright, what is 200 divided by 13? So you can get already the quotient. Okay, cuba guna kalkulator semua sekarang. 200 bahagi 13. 200 equals to, M equals to QN plus R. Saya nak kamu biasa dengan form ini, bentuk ini. M equals to 200 equals to Q times 13 plus R. What will be Q? Is 15 times 13. Okay, what will be the remainder? Okay, there are several
Remainder
things.
Dua.
Okay. Kalau kamu tekan calculator directly, ni saya cuba alami tunjuk proses student. 200 sama dengan 15. Bagi 3 kamu dapat 15.38, betul? Pada mulanya, kamu tak akan dapat lagi R directly. So, how to find the R is actually very simple. R can be determined by 200 minus 15 times 13. Dapatlah 200 tolak 12 ke 13. 5. So, at the end, 200 equals to 15 times 13 plus 5. Okay. There are few points to remember on how to represent remainder correctly. First of all, remainder, 2 points. Remainder must be positive must be non-negative, dia boleh kosong. The second one is that the remainder must be less than the divisor. This is how you represent division algorithm correctly. Condition for the division algorithm to be correct. You don't get my point yet. Sekarang ni saya nak kamu semua tahu dulu yang ni. Okay, what happens? 200 equals to 14 times 13 plus, it becomes 18 here. Mathematically, this is correct. This linear equation is correct. But it is not correct by division algorithm form. It means that you still can divide 200 more by 13, but you don't finish it. If you look at the remainder here, it violates condition number 2 because 18 is larger than 13. Therefore, it still can be reducible to 15 times 13 plus 5. So yang ni, although it's correct in terms of linear equation, but it is wrong by division algorithm. That is one thing. One more thing is that I can represent 200 equals to 16 times 13. But if 16 times 13, I need to minus 8, betul? In terms of mathematical linear equation again, this is correct. But it violates condition number 1. The condition number 1 is that the remainder is always a non-negative. Therefore, this 16 actually can be changed into 13 plus 5. In order for you to represent division algorithm correctly, it must satisfy this condition, is that remainder must be non-negative and it must be less than the divisor. This is how you divide correctly. Perasan tak dulu, kalau bahagi mana ada negative remainder? Because remainder cannot be negative. Okay? Ada soalan setakat ini sebelum saya proceed? Ini violate R less than divisor. Ini pula violate R must be larger than 0.
Sir, kalau
Ya.
guna kalkulator dapat?
Ha?
Kalau guna kalkulator kan,
Aha.
lepas tu jawapan tu kita tukar ke fraction.
Okay.
Saya dapati bahawa QN dengan R tu kita dapat melalui kalkulator terus.
Boleh tunjuk? Saya tak dapat nampak idea awak. Okay, contoh lah. Saya cuba ambil idea awak. 200 bagi 13. Okay. Dapat apa dalam kalkulator kamu? Fraction.
Fraction. 15, 5/13.
15, 5/13. So 15 yang kat depan tu ialah dia punya quotient. Itulah 15. Kamu ambil 15 tu, masuk dalam tu. Yang 5/3 tu adalah sebutan apa tu? Saya tak ingat lah term dia awak, tapi dia proper fraction ni. Mix. Siapa boleh tolong saya? 15
Perfection.
apa dia? Ulang balik.
It's proper fraction. Kan?
Itulah dia. So awak ambil 15 tu, dia tu jadi quotient awak ke depan. Lepas tu yang 5/13 tu, nanti kita simpan dulu, kamu boleh cari R dalam bentuk yang saya tunjuk tadi tu. Yang penting sekarang ni, kita dah sampai ke sini. 200 kita log 15 ni, R ni kamu boleh cari dengan ambil 200, tolak 15/13, dapatlah 5 tu. Satu lagi cara yang Dr. Syam ajar saya dulu, okay, dia cakap macam ni. Ni saya cuba ingat balik cara dia. 200 sama dengan 15, 13. Dia dapat berapa? Tadi yang cakap dengan saya tu berapa? Kamu dapat tu 15?
15, 5/13.
Okey, 5/13. Okey. 15 ni okey lah masuk sini. 5/13 ni Dr. Syam ajar saya, ni sebab kamu keluar 5/13. 5/13 ni boleh cari R dengan cara remainder sama dengan 5/13 sebahagian daripada divisor 13. Jadi dapatlah jawapan dia 5. So kamu boleh guna juga cara ni, ambil 5/13 tu, 15 ni masuk ke quotient. Yang remainder ni kamu kena darab dengan divisor 13, dapatlah remainder terus. Boleh juga tak guna cara tu sebagai alternatif. Lagi cepat kan, tak payah nak tolak kan. Sama je, tak kisah nak ambil yang cara yang warna biru tu atau warna hitam yang baru saya letak ni. Okey, soalan lain? Okay, now kita tengok balik nota. Alright. Untuk case positif, dia senang. Okay. Tadi kita dah buat 200 dengan Q13. Okay. Kita teruskan dengan contoh yang sama. 200 sama dengan 15 kali. (15 kali 13 tambah 5). Okey. Dua benda yang kena ingat ialah div. Ada dua div dengan mod. Secara umum M ialah divisor, div N kamu akan dapat quotient. Kalau M mod N kamu dapat a remainder. In this example, if you represent this 200 div 13 berapa? Ialah kamu akan melaporkan quotient dia 15. 200 modul 13, you will get the remainder. I repeat, divisor div n. Saya tak nak kata divide. If I say divide, some student might be confused with divide factor tu. So saya suka cakap div lah, walaupun mungkin kurang tepat. Saya still akan cakap divisor div dividend div divisor dapat quotient, dividend mod divisor kamu akan dapat remainder. Ni semua ada solution, tu yang tak seronok. Okey, contoh saya bagi soalan lain yang untuk kamu jawab sekarang. Find 100 div 22 and then find 100 mod 22. Okay, in order for you to find whether the div and mod, it will answerable to find the division algorithm. Maksudnya kalau kamu nak cari quotient and kamu nak cari remainder yang betul, kamu kena baik kamu letak dia dalam bentuk division algorithm form, which is Q times 22 plus R. And because 100 equals to 4, 4 times 22 plus 12. Therefore, 100 div 22 equals to 4 and 100 mod 22 equals to 12. Betul tak 12 saya represent ni? Betul tak yang ni? Nak check dia ialah 12 must be less than the divisor 22, okay? And 12 is positive, okay. And then when I multiply back this equation, 4 times 22, 88 plus 12 will get 100. So betul lah representation saya ni. The representation of division algorithm is unique. The answer is unique. You cannot get another value of quotient and another value of remainder. Remainder tu unique. Solid 12, kamu tak akan dapat remainder lain. Bila remainder tu unique, quotient pun adalah unique. Okey, kita pergi ke contoh yang sedikit sukar. Jika case negatif. Find negative 100 div 22 and then D, find negative 100 mod 22. Okay, this one is a little bit tricky. Dan yang di sebelah kiri ni adalah dia punya tips. Okay, so please concentrate for the remaining this 5 minutes. Concentrate. My advice to the student is try to treat this negative 100 as an 100. Contoh, negative 100 sama dengan bahagi 22 kamu dapat negative 4 times 22. Okay, R ni pula kamu akan dapat negatif. Jadi negative 12. Okay, fair enough. Again, if you put your answer like this, then this is not division algorithm kerana remainder dia negative 12 kat sini. So you need to process it. You need to add up additional further step so that it can be correct such that remainder is positive. So the way to do that is that saya modify kat sini New R equals to all R plus divisor. Whereas for the quotient, the new quotient is equivalent to the old quotient. You need to minus one more. Okay, by using these tips, negative 100, negative 4 is the Q right now. You minus one more. Negative 5, 22. Ni. Negative 4 minus 1 becomes negative 5. For the remainder, you add up with the divisor. Divisor yang mana dalam kurungan ni? 22 minus 12 becomes plus 10. So actually negative 100 in division algorithm form by divided by 22, it becomes negative 100 equals to negative 5 times 22 plus 10. This will be your representation. Let us check by multiplying back negative 5 and 22. You plus 10 dapat negative 100. So correct. For the quick check or multiply, the 10 is less than the divisor 22 and also is positive. All conditions checked. So the new quotient will be negative 5, the new remainder will be 10. You put back into the answer, negative 100 div 22 is negative 5, whereas remainder is 10. Nampak beza jawapan dia? Cuba compare the case where the 100 is positive and when the 100 is negative. Yang ni 4, 12, yang ni negatif 5, 10. Saya berkecilkan. So don't let your answer be in this form. In the case of negative dividend, you must process it so that the remainder satisfy the condition. This is how you represent division algorithm correctly. Okay, so untuk latihan seterusnya nanti saya akan share video ni petang ni lepas saya download apa semua. Try to do exercise in the tutorial. Dalam tutorial 1 DMS yang masih mengikut struktur DMA, tak ada masalah. Kamu cari number theory, kamu dah boleh jawab beberapa soalan dalam prime factorization and GCD and LCM and also for some basics of division algorithm. Kita buat satu latihan terakhir sebelum saya habis lecture ni. Saya nak kamu cari soalan ni. Mudah saja, saya cuba buat 73 div 8. Okay, cuba buat. Saya dah tahu jawapan dia. Dah buat boleh share. Saya nak tengok kalau in case student ada masalah. Musin jawab. Sekejap. Okey, Imran dapat semua. 9, 1, negatif 10, 7. Okey, saya simpan dulu. Saya tak kata jawapan Musin, Imran dengan Arisha ni confirm betul. Kita masih kena saling semak. Betul? (73) equals to 9 times 8 plus 1. So 72 plus 1. For the first question A, B, betul saya rasa. Confirm betul. Remainder is less than 8 and is positive. Thank you. Saya rasa itu tak boleh nak deny. Betul. C dengan D. Negative 73. Negative 10 kali 8 tambah 7. 7 is smaller than 8 and is positive. The last thing I need to check is negative 8 plus 7. It will be correct. Very good. Imran, kamu faham dan saya harap yang lain pun cuba catch up untuk dapat idea untuk kita faham macam mana case untuk cari especially for the negative dividend. Okay, this sums up the lesson for today, but the division algorithm punya skill we need to master that so much because it will be used for the next lesson of Euclidean algorithm. Euclidean algorithm is another method to find the GCD by utilizing the concept of division algorithm. Jadi kena mahir dulu represent apa-apa dua integer dalam bentuk division algorithm. Okay? Sebelum saya habiskan lecture ini, ada apa-apa soalan berbangkit? Ialah soalan Akram. Okey, saya lupa soalan Akram. So bagi masa sikit. Okey, Akram, nyatakan soalan anda.
Okey, sir. Apa ni? Untuk apa ni? Primality test tu kan? Kalau kita nak test dia prime number ke tak, so mula kita square rootkan dia kan?
Betul.
Okey, lepas tu kita try lah apa ni, bahagi dengan apa ni, prime number kan?
Ya.
Sampailah contoh kalau kita bahagi apa ni, kita bahagi 1001 kan? So kita akan dapat 31 point something kan?
Okey.
And then lepas tu bila saya try, then kalau 1001 bahagi 7, so dapatlah apa ni, integer. So maksudnya dia bukan prime number kan?
Betul.
Lepas tu macam mana nak justify? Ke biar macam tu je buat kesimpulan?
Alright. Soalan Akram saya ulang balik ialah about the 1001 is prime or not just now. And if you want to determine whether this is a prime or not, then you need to find at least a prime factor. Kalau dia ada prime factor up until less than the square root of 1001, where Akram say is around 31 point something. So the normal process for you to achieve that is that you need to find is there exists a prime factor from the smallest prime 2 up until 31. 2 does not divide 1001. 3 does not divide 1001. 5 does not divide 1001. And eventually you will arrive here, 7 divides 1001. So it means that 7 is a prime factor of 1001. It's enough for us to justify that as 7 divides 1001, 1001 is not composite. It is composite. It's not prime, is composite. Cukuplah. Kerana untuk kita establish nombor itu composite, dia kena ada prime factor sehingga dia mesti ada prime factor up until 31. Cukuplah tunjuk bukti ini. Kalau kamu nak jump straight kepada ni boleh. Dan macam kawan-kawan kamu yang lain dia cakap 13 pun adalah faktor prime factor kepada 1001. Cukuplah. Itu orang panggil dia bagi tahu ada existential. There exists some prime factors other than 1001 itself. Kalau 1001 is indeed the prime, dia tak ada dah prime factor up until 31. Cukuplah jawab ini saja, saya dah terima dah. Okay? Soalan lain? Oh, okay. Good, Tengman. Thank you for sharing. Ya, sama-sama. You buat sendiri ke, Tengman? Google Form code tu. Bagus kawan kamu Tengman dia dah share pasal coding. Ini coding. Kamu boleh tengok lah WhatsApp, semua boleh tengok lah WhatsApp sekarang. Apa ni? Prof UMP tu. Apa Prof UMP? Saya suka dia share, tapi ini dalam bahasa C, ya. Lain kali kamu sebagai data scientist, kamu kena practice benda ni, biasakan dengan programming asas, dan kamu bukan saja akan belajar dalam bentuk C, dan kamu akan belajar dalam bentuk Python. So boleh buat. Lagi best kalau kamu boleh buat balik the coding tu. Sebab saya tahu banyak yang belajar coding ni as simple, saya pun sama, we tend to copy first, nak bagi faham, copy. The way there is a learning process up until the end you manage to produce the code by yourself. But to understand the coding, you need to have a pseudocode, you need to have the flowchart. Kau nak tengah belajar kan Sammy kan? Flowchart tu kena betul, logic gate, logic punya flow tu kena betul. Dan asas logik ialah DMS. DMS adalah asas logik tersebut, and then some arithmetic proving is needed. Okay, cukuplah sekat ini. Ada soalan lain tak? Okay, jika tiada, 10 saat. 1, 2, 3, 4, 5, 9, 10. Apa ada ini Towi ni? Alright, saya stop recording. Oh, tahu tak yang video anak Encik Towi korang tayang ni akan ada dalam YouTube Okay.